This video covers 7.5 adding and subtracting rational expressions with unlike denominators. There's only one objective: to add and subtract rational expressions with unlike denominators. I will split this video up into two different parts. This one will be for part 1. Couple of practice problems to get us started. We've talked about denominators that are opposite pairs already. It's crucial that we recognize opposite pairs because getting a common denominator is pretty quickly when you have opposite pairs as your denominators. Remember that x minus 7 and 7 minus x are opposites of each other. That means we can always write 7 minus x as the opposite of x minus 7. So we replace the 7 minus x with the opposite of x minus 7. And then we recognize that when you add a negative number or a negative expression, you're really subtracting. Now that I'm subtracting, I make sure to distribute that subtraction as a negative sign to both of my terms. When I do that, I get x squared minus 6x minus 7 divided by x minus 7. Now we simplify, and the numerator factor says x minus 7 times x plus 1. When we divide that by x minus 7, we cross those out and we just get x plus 1. So opposite pairs as denominators, real quick fix for that, we turn it around and change the operator, plus to minus. We've also talked about how to find LCDs. This is super important for today, for this video. Finding the LCD, we list each different factor we see. This one has a 3 and an x minus 2 and an x plus 2. The 18 has a 2 times 9 or 2 times 3 squared, and then this is x minus 2 times x minus 2. So our LCD must have all of the different factors: 2's, 3's, x minus 2, x plus 2. And then we list it according to the one that has the most. So there's 1, 2 sitting here. There's 2, 3 sitting there. We have 1 x plus 2 sitting there, so 1 goes in, but we have 2 x minus 2's. According to the one that has the most, there's 2 of those that go in there. So 2 times 3 squared is 2 times 9, which is 18. We got 2 factors of x minus 2 and 1 factor of x plus 2. All right. So now we use the common denominator, the least common denominator, to build our fractions up with that denominator and then add or subtract as indicated. So part 1 of this video for 7.5 is going to be the addition. So to get us warmed up with rational expressions, we look at 2 fractions. If our denominators are 12 and 18, we factor. 12 is 2 times 2 times 3. 18 is 2 times 9 or 2 times 3 times 3. Our LCD must have all the different factors, a 2 and a 3, according to the one that has the most: 2 2's, 2 3's. So we get 2 squared is 4 times 9, which is 36. All right, so I'm going to use the language today of what I want to have as my denominator and what I have. What I'm missing is what I put in the top and the bottom. So if I have a 12 and I want 36, I'm missing a 3. So I put in the top and the bottom, giving me 15 over 36. If I have an 18 and I want 36, I'm missing a 2. So I put it in the top and the bottom, giving me 14 over 36. Adding this together, I get 29 over 36. Try to simplify that, but there's nothing that will be common top and bottom. Okay, so we're going to find the LCD, figure out what we're missing on each fraction, multiply top and bottom, and then add straight across the top and try to simplify. So if we have denominators that are 8a cubed b and 12ab squared. 8 is 3 factors of 2. 12 is 4 times 3. So our LCD has to have 2's and 3's and a's and b's. The largest number of 2's I see is 3 of them. The largest number of 3's is 1 of them. I have 3 a's or 1a, 3 is larger. 1b or 2b's and 2b's. So 2 cubed is 8 times 3 is 24. A cubed b squared. So this is what we want. And now we go over here and say, well, I have an 8a cubed b, and I want 24a cubed b squared. So I'm missing a 3 to get 24. I have the a cubed, and I want b squared, so I'm missing a b. So I put in the top and the bottom. That gives us 3b over 24a cubed b squared. All right, the next fraction, the denominator of 12ab squared, and we want 24a cubed b squared, so we're missing a 2. We want 3a's, we have 1, so we put in another 2. We want b squared, and we have just b squared, so we multiply top and bottom by 2a squared. Multiply the numerator, giving us 10a squared divided by 24a cubed b squared. Now our fractions are built up with the same denominator, so we add straight across the numerator, giving us 3b plus 10a squared divided by 24a cubed b squared. The numerators, nothing I can factor out of that. Therefore, there's nothing we can do to simplify this. There's our answer. Example 3. Our denominators are x minus 4 and x plus 2. They're completely factored, and they are totally different, nothing in common. When that's the case, when you form your LCD, all of the different factors have to go in the LCD, according to the one that has the most. Well, there's only one of these x minus 4s and one of these x plus 2s, so that is my LCD. So these are kind of the easiest problems. When your denominators have nothing in common, the LCD is just the product of the two denominators. I always like to remind you that if you were to add 1/2 to 1/3, same thing there, you would use the product, which is 6. 2 goes into 6 3 times. 3 times 1 is 3. 3 goes into 6 2 times. 2 times 1 is 2. So we think of this kind of as a swapping thing. 3 and a 2, and then 3 plus 2 is 5, 6. So our example, we have 5 over x minus 4, 3 over x plus 2, and we want to have an x minus 4 and an x plus 2. So my first one is missing the x plus 2. The second one is missing the x minus 4. When the numerator is an x plus 2 and a 5, we have to distribute that 5 to both terms. Now we have a common denominator, plus. The 3 needs to be distributed to the x minus 4, divided by our common denominator. Now we multiply across the tops there, 5x plus 10, 3x minus 12, and now we have it all over the same denominator. That gives us 5 plus 3 is 8x. 10 minus 12 is negative 2. We can factor out a 2 from the numerator, which leaves us with 4x minus 1. and that's not going to match up with anything down in the denominator, so that's simplified. That is our answer. All right, practice 1. This is your chance to practice this. I encourage you to press pause in your video, see what you get, and come back and check the solution with what I get. All right, now that you've had a chance to work this out, I'll work this out with you. Our LCD is just the product of those two denominators, an n minus 3 and an n plus 1. So my first fraction, we multiply top and bottom by n plus 1. My second fraction, I multiply top and bottom by n minus 3. We distribute the negative 1 to the n plus 1. We distribute the 4 to the n minus 3. We distribute those across, we get negative n minus 1, 4n minus 12. Negative n plus 4n is 3n. Negative 1 minus 12 is negative 13, divided by n minus 3 and n plus 1. 3n minus 13 is completely factored, doesn't match anything in the denominator. So that's our answer. Example 4. Now we have some denominators that have something in common. X squared plus 5x is x times x plus 5, and x squared minus 5x is x times x minus 5. Our LCD then has to have all those different factors, an x plus 5, and an x minus 5. So we start off with 1 over x squared plus 5x, and we see what we're missing. We have the x and the x plus 5, we're missing the x minus 5. So I put it in the top, and I put it in the bottom. My second fraction, 1 over x times x minus 5. I'm missing the plus 5. All right, so the first one is 1 times x minus 5, which is x minus 5. The second one is 1 times x plus 5, which is x plus 5. And now we have this all over the same denominator, which gives us 2x. Negative 5 plus 5 is 0. We have 2x over x times x plus 5, x minus 5. So our x's cancel, and we're left with 2 over x plus 5, x minus 5. Example 5. We have some factors in common in these denominators, so we need to be careful with choosing our common denominator. LZ plus, 7z plus 10, and then we have a z plus 5. So this one is z plus 5 and z plus 2. So our LCD has to contain the z plus 5 and the z plus 2. All right, so what do we have? First fraction, negative z plus 1 divided by z plus 5 and z plus 2. Second fraction, 2 over z plus 5. We see that they both already have a z plus 5 in common. So that means my second fraction is missing a z plus 2. So I put it in the top, and I put it in the bottom. My first fraction is negative z plus 1 plus 2z plus 4. all over the common denominator, z plus 5 and z plus 2. So notice how I don't ever multiply the denominators, but I do the numerators. 2z minus z is z, and 4 plus 1 is 5. Divided by z plus 5, z plus 2. We see the factors z plus 5 in common, so we cross them out, and we're left with 1 over z plus 2. So now is your chance to practice. Please press pause on your video, see what you get for this problem, and come back and see if your answer matches what I get. All right, so now that you've had a chance to work this out, our denominators are x plus 2 plus a negative 8 over x minus 6 and x plus 2. So I see that my LCD must contain an x minus 6 and an x plus 2. We see that we already have the x plus 2. So we multiply top and bottom of this fraction by what we are missing, which is the x minus 6. It's important you use the parentheses on those. We have to FOIL out the x plus 1, x minus 6, giving us x squared minus 6x plus x is minus 5x minus 6. We're all over that same denominator now, so we have a plus 2 and a minus 6. And our numerator from this one is a minus 8. So plus a negative 8 is just a minus 8. So now we have to collect the like terms in the numerator and then try to simplify. That's x squared minus 5x minus 14 over x plus 2, x minus 6. So we factor the numerator as x minus 7 and x plus 2, leaving us with x plus 2, x minus 6. So we cross out the x plus 2's, and we're left with x minus 7 over x minus 6. This concludes this video on 7.5 adding and subtracting rational expressions with unlike denominators, part 1. In the next video, I will do the rest of it, which is the subtraction, and that will be in part 2.